Hi guys, and welcome to the video for the surface area of pyramids. So in this video, we're going to go over how to calculate the surface area of a pyramid. We're doing this because some shapes are pyramid-like in nature, and you may need to calculate the surface area for how to cover them. And then it also gives you an idea of when you talk about stuff like the Great Pyramids of Giza, it really gives you an idea of how impressive those accomplishments were and how massive they were to build. You'll know you're successful when you can find the surface area for a right regular pyramid, which we will go over in this video. So, you can pause here if you need more time to write, but what is a pyramid? When we think of pyramids, we think of the Great Pyramids of Egypt. They're actually square pyramids because their base is a square, but the actual definition is that a pyramid is made by connecting a base to an apex. So, the base is a polygon, some sort of flat shape with straight edges, and all of the other faces are triangles because you'll have one side that touches the base, and then the other two sides are used to join the other edges to an apex, or a point where all of the sides meet. So apex meaning the point where all of the sides meet. And you can kind of see the two definitions here. I have base written on this pyramid, and then the apex is up at the top where all of the points meet. So this would be a point in three-dimensional space where all four sides of this pyramid meet. There are no curves in a pyramid. So, types of pyramids. There are an unlimited number of pyramid shapes, each named after the type of shape that creates the base. The three most common are triangular, square, and rectangular. Those are the three types of pyramids that we see the most. We can also classify pyramids as regular or irregular, so you can kind of see the difference above. Regular meaning that the base is regular shaped, and that they are either right or oblique. For our purposes, we're going to usually focus on right regular pyramids. So they might not always have 100% regular bases because they're rectangular, but for the most part, they're very easy to calculate shapes. Very easy to calculate the area shapes. So with that, we can create what's called a net. So unfolding a pyramid, this creates a net. I just want to mention that because it is specifically called a net. And the net is this figure on the right. So we can unfold a pyramid to better understand how to calculate its surface area. As you can see below, the square pyramid is made up of a square on the bottom as its base, and then four attached triangles. If you unfold the triangles and make it so they don't touch each other anymore, you get the figure from the one on the left unfolds into the one on the right. So it unfolds into. So it gives you a good idea of what you would have to do to find the surface area. You could find the length of one of those triangles and multiply by 4 to calculate the lateral area of the pyramid. Now, lateral area is the area of the non-base sides. So I'm going to define that for you again. Make sure you write this down. The lateral area is the combined area of all non-base sides of a pyramid. So all of the non-base sides of a pyramid. So all of the triangles essentially in a pyramid. So instead of non-base, I'm going to write triangular sides of a pyramid. Now, the formula is it's adjustable. It takes this form to calculate the surface area of a pyramid. We use this adjusting formula that the surface area is equal to the base area. I want to make that clear. It is the base area plus the lateral faces area. So what I mean by that is you need to calculate the area of the base and you need to calculate the area of the lateral faces, and you're going to combine those two amounts. It's adjustable because the formula isn't really set in nature. The formula changes based on what kind of figure the base is. And then it also changes based on how many lateral faces we need to actually calculate in order to find the total sum of lateral faces. So I'm actually going to write plus the sum of all lateral faces area. So let's just jump into some examples right away. Here I have a triangular pyramid, and I am asked what is the surface area of this triangular pyramid. What I could do is note that there is a triangle as my base, and they say there's 4.5 on this side centimeters, and that the height of the triangle, this fictional segment that makes a 90-degree angle, I don't like the 90-degree angle marker, there it is, with the base is 3.9 centimeters. And then what would have happened was if we unfolded, so I'm going to take out my line tool here to make it more precise. If we would have unfolded the pyramid, we'd have three shapes like this, and I don't think I went far enough over. So yeah, it doesn't look like it's meeting in the middle. So you'll have to excuse, I'm going to just adjust the net here so that it looks more accurate. But the sides are the same, and yeah, we're going to adjust this one to make it look a little better. Okay, what I am then going to do is note that each one of these lateral faces has a height going up and down like this of 3.5 centimeters. 3.5 centimeters. So the information that I am able to get out of this whole thing is that the base is equal to 4.5 centimeters. That is the length of one of the bases. The height of the base is 3.9 centimeters. And the lateral facing, L, has a height of 3.5 centimeters as well. So that is information that I was able to get out of this. What I am going to do is then use that information in order to calculate the area of all of the triangles and then sum them together. So the 4.5 refers to this segment here. So let's calculate the area of the base. So the surface area is equal to the base plus the lateral faces. So the base area, I should say it's the base area. The base area, in this case, we need to calculate for a triangle. And the lateral faces here, we're going to have 3 triangles. So we're going to go ahead and calculate the area of the triangle that makes up the base. So the surface area here, if I look at just this portion, and I'm going to use a highlighter here, so I'm going to pull my highlighter. If I look at just this triangle right here, the one that's with it on the bottom, the base, it has an area. We need to remember that the formula for area of a triangle is 1/2 times base times height. So if I substitute base and height in there, I would get the area is equal to 1/2 times 4.5 times 3.9. And so I can go ahead and punch that into my calculator, half times 4.5 times 3.9. And the base area would be 8.78 centimeters when you round it to the nearest hundredth centimeters squared, plus, and now we have to do 3 because we have 3 lateral faces, and we're going to multiply that by the area of one of the lateral faces, since all of the triangles are the same. So to calculate the lateral faces, that area would be, again, 1/2 base times height, because we are still working with a triangle, but it'll be 1/2. The base will be 4.5 again, but the height is not 3.9. Instead, and I'm going to just go back and correct something up here. Instead, what we're going to use is the 3.5, since the 3.5 is the lateral height, the L of the triangle, and I'll highlight the triangle in green that I am talking about. So where's my highlighter? Do it in green. This triangle here has a height of, use the smaller highlighter here, 3.5 from here to here. So because of that, we're going to be using the 3.5 measurement here. So I'm going to substitute 3.5 into my equation instead of 3.9. So we do 0.5 times 4.5 times 3.5, and we get the area of one of these is equal to 7.88 centimeters squared when we round it. So we're going to put 7.88 centimeters squared in here. And I'm going to multiply 7.88 times 3. And I get that the surface area of this triangular pyramid is equal to 8.78 plus 23.64. And then I'm going to just add those together. So 8.78 plus 23.64 is going to be 32.42 centimeters squared. So the total surface area of the pyramid is 32.42 centimeters squared. Okay, so now we're moving on to a square pyramid. What is the surface area of the square pyramid here? So again, we could unfold the pyramid in order to gain a better understanding of it, but I just kind of wanted to show you what that was like once. If I were to unfold this one, and I'm going to try to do it really quickly here so that the video doesn't get too long, I'd have a square, and then I would have a triangle like this, and then I would have a triangle on this side here, this side here, and this side here. And then I could apply the measurements that I have here. So the first measurement would be 16 inches here, and then 16 inches going up this way. So that would give me the two measurements of the square. And then I could also put in the height of the triangles. It's not quite to scale, but it's close enough. So the height of the triangle here, let me just erase some stuff here, is 17 inches. So that's really all I need. And then that 17 inches could be applied to this height and this height and this height as well. So now it's time for me to go ahead and calculate the surface area. So the surface area is equal to the base area plus the lateral face area. So in this case, the surface area would be equal to a square, which we would do, the area of a square is just base times height, and both of them are the same, so the area would be 16 times 16. So the total area here would be 256 inches squared of the base. So we'd have 256 inches squared plus we have 4 triangles that we're going to calculate the area of. And we're going to calculate the area of the triangles just over here quickly. The area is equal to 1/2 times the base times the height. The area is equal to 1/2 times 16 times 17. Okay, so we'll type in 0.5 times 16 times 17. And we get the area of one of these triangles is equal to 136 inches squared. And I overestimated how big I needed to make my parentheses. So then what we will do is just simply add those amounts together. 250, we'll do 4 times 136, which is 544 inches squared. So if we add the two amounts together, 256, sorry guys, 256 plus 544 is equal to 800 inches squared. And that's the surface area of this square pyramid. And then the next one we're going to do is a rectangular pyramid. So I'm going to unfold the shape just so you kind of get an idea of the kind of shape that we're dealing with. So we would have a rectangle like this, and we'd have some different measurements here. The first measurement would be that this is 6 meters. The next measurement would be that the side here is 2 meters. And now we're going to have two different types of triangles here. We are going to have a longer and thicker triangle here. And then we're going to have a skinnier triangle. It's going to look more like this. So I'm going to try to flip it and match it. So just give me a second here. Flip it and then scale it to match. Okay, so I'm going to quick clone this and then flip it. Flip, up, down, there we go. Clone it and flip it. So this is what it would unfold into. There are 2 more measurements that we need to put on though, now that we've done that. The next one would be that the longer and thicker side has a height of 8.8 meters. I'm using color coding to keep all of our measurements the same. So then this height over here would also be 8.8. And then the next one here has a height of 9 meters, and it would be the same on this side as well. So I can go ahead and start writing out my formula for surface area. The formula for surface area is equal to the base area plus the lateral faces. I'm write LF for short. I have a rectangle on the base with a base of 2 and a height of, or a base of 6 and a height of 2. So the surface area is going to be equal to 12 meters for the base. Again, it's the 6 feet or 6 meters times 2 meters. That makes the area of the rectangle. Plus, now I have 2 sets of 2 lateral faces. So we're going to have 2 times one of the sets of lateral faces and 2 times the set of the other lateral faces. So if we do the blue lateral faces first, we have that the area of the blue would be 1/2 of 2 for the base times a height of 9. So 0.5 times 2 times 9 is 9, because 2 and 1/2 cancel each other out. So we're going to have 2 times 9 meters squared in here. And then the other one that we're going to do is we would have that the area is equal to 1/2 times the base of 6 times the height of 8.8. So half of 6 times 8.8 gives us 26.4. So we have two lateral faces that have 26.4 meters squared as their area. And now I'm going to multiply everything out here. The surface area is equal to 12 meters squared plus, this would be 18 meters squared plus 52.8 meters squared. And then we're going to add them up. 12 plus 18 plus 52.4 is equal to a surface area of 82.4 meters squared. So this one has a surface area, this rectangular pyramid has a surface area of 82.4 meters squared. And then we're going to do an application problem. This is number 8 from your homework sheet. So you can write it down, or you can pause, pull up the homework sheet, and you can do it. Make sure you include it in your homework. But let's get started. The Great Pyramid of Giza stands at 405 feet tall from base to top. The length of the base is 756 feet approximately. What is the surface area of the 4 triangular facings? Okay. So they say 4 triangular facings. That's code. That is code for lateral faces. They want us to calculate the lateral faces. So in here, the lateral faces is equal to 4 triangles. 4 triangles. We don't even need to calculate the area of the base because we only want the lateral faces. So let's examine the diagram. I have a base 756 feet. This here would also be 756 feet. And then I have this dotted triangle. They say that it is 405 feet tall from base to top. So this segment here, the straight up inside the pyramid segment, is 405 feet. That measurement would be directly from the apex, which straight down would be in the middle of the square here. And that would intersect at a 90-degree angle. And the measurement from a base to the middle would be 378 feet. And that's important because what we don't have is this. We do not have this measurement here in red. We are missing L, which is the lateral height of the pyramid. In order to find it, what we need to do is use the right triangle created here and use the Pythagorean theorem to calculate the length of L. L is the hypotenuse, so it's easy enough to do. So we just need to do the Pythagorean theorem. 378 squared plus 405 squared is equal to L squared. So you're definitely gonna need a calculator for this, because these are some pretty big numbers. 378 squared is 142,884. 405 squared is 164,025. And that's equal to L squared. So if you combine 142,884 plus 164,025, on the left side of the equation, you're going to get 306,909. And that's equal to L squared. So I'm going to take the square root of that. So take the square root of that and take the square root of L squared. And I would get that L is approximately, and this means I'm rounding it, equal to 554 feet. The actual answer on my calculator was 553.993. So if we round it, it turns into 554 feet. So now that I know that, if I were to unnet this, one of the triangles on this pyramid, on the Great Pyramid of Giza, oh boy, would have a base, here we go, it's a little better, of 756 feet, and it will have a height here. I'm struggling with my straight lines today. 756, and it would have a height this way of 554. So then I can calculate the area of that. The area of one triangle would be 1/2 of the base, 756, times the height, 554. So the area here would be 756 times 554 times 1/2, which is 209,412 feet. So now I need to take that and multiply it by 4. So I'm going to do the lateral face here is going to be equal to 4 times 209,412 feet. Feet squared. So multiply that amount by 4, and the total area, the total surface area for all of the sides, the lateral faces, I need to shrink this so I have some more room to work with, comes out to a whopping total of 837,648 feet squared. That is a lot of stone to create the Great Pyramid of Giza. So in summary, that's it for the video, guys. We learned what a pyramid is today and how they're classified. We learned that we can unfold a pyramid to help understand its construction and then to better calculate its surface area. We went through 3 examples of finding surface areas of various right regular pyramids, which is kind of the focus for this section. And we went through an application problem for the surface area of a pyramid, specifically a real-life pyramid, the Great Pyramid of Giza. If those measurements are accurate, now you know the surface area of the Pyramid of Giza, which would be a cool little trivia fact to know for the future. That's it for today's video, guys. Thanks for watching, and I will see you in the next one.